Boys, I'm going to show you an example of displacement. And displacement really means pushing something out of the way. And it's always the strongest, most reactive thing that pushes things out of the way. And I'm going to demonstrate. I have got 3 chemicals here. That is copper sulfate, zinc sulfate, and magnesium sulfate. And I've got 3 types of metal. I've got magnesium, zinc, and copper. And I'm going to add them all together, and we're going to see what happens. Firstly, let's do the copper sulfate being added to the 3 different types of metal. Copper sulfate on magnesium, copper sulfate on zinc, and copper sulfate on copper. And it looks like something's happening. Right, let's try zinc. Zinc on the magnesium, zinc sulfate on the zinc, and zinc sulfate on copper. And the last one, that was magnesium sulfate on magnesium, magnesium sulfate on zinc, and magnesium sulfate on copper. Well, looking at these, all the action's going on here. They've gone black. These bits of metal have gone black. It looks like some sort of reaction. Now that tells us that the magnesium is more reactive than the copper. The copper is in the magnesium, the copper is in the copper sulfate. The copper is attached to a sulfate. But this magnesium has come along and just pushed the copper out of the way. It's just displaced it. Similarly here, the zinc is more reactive than the copper. Remember, the copper is in the liquid, the copper sulfate, and the zinc has pushed it out of the way. Over here, though, we can see, well, there's a little bit going on here. Just here, we can see that actually the magnesium is more reactive than the zinc. The zinc was in the liquid, the zinc sulfate, and that has pushed it, and there's a reaction and it's bubbling away. But in the last column, the last row, when we added magnesium sulfate to these 3, absolutely nothing happened. The magnesium is very strongly attached to the magnesium sulfate. Magnesium does nothing. Zinc can't push the magnesium off the magnesium sulfate, and copper can't push the magnesium off the magnesium sulfate. So that tells us the most reactive one, the most reactive metal is the magnesium, and then the zinc, and then the copper. Copper's rubbish, but it does look nice. That is a nice bluey colour, isn't it? You cannot argue with that colour. Boys, I'm going to show you a displacement reaction. A displacement reaction is where there are 2 substances and one is more reactive and it will push something else out the way and grab whatever it was grabbing onto. So in here I have got aluminium and iron oxide. We should see that aluminium is more reactive and it'll push the oxide off the iron. It'll displace the iron and it'll be a big reaction and it should leave behind the iron. This bit here is magnesium. The magnesium doesn't really play any part in it, that is just because it needs a lot of heat to get going. And you are aware that magnesium doesn't half go. Let's heat it up. Right, that's the fuse. The fuse is lit. Right, now I'm looking at that, I can't see a lot, I've just got a great big green spot in front of my eyes and I can't see. When that's cooled down, we're going to look in there and hopefully we're going to find a piece of iron which has been pushed away from the iron oxide. Alright, let's see if we have some iron. I'm going in with a magnet. Oh, don't want to stick to this, I'll hold that still. Right, those bits there that are stuck to my magnet, those are bits of iron. We have just made pure iron by displacement. We have displaced the iron from the iron oxide by using aluminium. All right, there we go.